Hello there. My name is Chris Huffman. I am the owner and operator, head machinist, head janitor, whatever you want to call, of Huffman Machining Solutions. Huffman Machining is a small job shop specializing in historic preservation of steam locomotives and other historic machinery. We're located in Newland, North Carolina. Newland is a small rural mountain town. It's starting to get a little bit bigger these days, but a small rural mountain town just along the Tennessee border, about 45 minutes south of Boone, North Carolina, about 2 hours north of Asheville, if you know where that's at. There's not a ton of industry in this area. So when I was getting started, a lot of people didn't know what a machine shop was. A lot of people thought that I was going to be doing some welding or some metal fabrication like blacksmithing. But as time's gone on, there's been a lot more industry moved to Western North Carolina, most notably a lot of aerospace companies. Pratt & Whitney has built a facility in Asheville, North Carolina. And we also have a very strong community college system here that is very, very heavily involved in a lot of trade applications, machining being one of them. I got my start in machining in 2016, so I've not been in this as long as a lot of people out there that own their own businesses, but I've seen a lot in the last couple years, and I want to just take a couple minutes to talk about my journey and where I'm going and where I've been and what I hope to do in the future. So if you ask my parents or anybody that knew me growing up, they would say that I was the train kid. I love steam locomotives, I love historic machinery, I love old machinery, not just trains, but tractors and all that sort of thing. And growing up, I wanted to go work for a tourist railroad. And I wanted to figure out any way that I could go work for a tourist railroad because it just felt like that was the natural thing for me to do. Getting a little bit older though, I started having the realization that maybe that wasn't the right thing for me to do. I'm a husky boy. I'm a little big for that sort of work. But I knew that I still wanted to do something in that field or related. So I thought, well, how can I get into this? And a lot of people told me, you need to learn a trade. And I thought that I would, learn welding or something like that. And the community college, or early college, I should say, I was an early college student. At the time, I was able to go into a new applied engineering program the community college started. And this applied engineering program had a pretty heavy concentration in both manual machining and CNC machining. Well, even though I went to school and wanted that program to sort of do the tourist road thing, as I got into the machining part, I realized I loved machining just as much as I did trains. So there was just something so satisfying about taking a raw piece of material and turning it into something functional. And never mind the fact that everything that we interact with on a daily basis has been machined in some way. So I started taking a CAD/CAM class in 2016. After going through the program within the first year, I was able to get a job at a machine shop in Morganton. This machine shop did precision one-off machining. I cut my teeth on a prototract bed mill. We also built hydraulic fixtures and things. And I didn't stay there a ton of time, but I was able to learn a lot of the foundational stuff for machining. And I was able to sort of learn how a business that does machining operates. And I also saw a lot of stuff that I didn't particularly like. And I told myself, if I ever start my own business, I won't do this and this. Not to rag on the company that I work for, because they did, hire me when they didn't have to. Someone fresh off the street, out of school, is not going to know everything that someone who's well seasoned is going to know. But I ended up leaving there, and I knew that I wanted to at least get a little bit higher education and an associate's degree. So I looked around. I ended up attending Western Carolina University through their distance engineering program and received a bachelor's degree in engineering technology. I thought, if I don't go to the tourist railroad industry, I can at least go work for one of these aerospace companies and make a pretty nice living and maybe make enough money to open my own shop someday. Well, I was graduating in spring of 2020. And we all know what happened in the spring of 2020. So getting jobs and trying to find somewhere that would hire someone straight out of school with some amount of practical experience, but not a ton, was very difficult. Nobody wanted to talk about hiring because nobody knew what was going on. So I ended up talking to, and I had been involved with the community college that I went to previously, but they had unfortunately had an opening in their applied engineering department, and so I kind of stepped in and started teaching some of their machining classes, specifically the CNC, the CAD CAM, jig and fixture design, you name it. And in the spring of 2021, they hired me full time. So very young person in education. A lot of people might frown upon that, but I have really enjoyed working with a lot of younger kids, younger than me at least, and some older folks coming back to get a new education. So we teach them SolidWorks, we teach them CNC machining and all that. Well, one of the things that I kind of wanted when I went to work for the community college was the ability to use the machines to do projects and things. Not necessarily to make money, but so that I could help out my friends that were in the rail preservation industry. And I quickly found out that by the time I met all of the requirements as an instructor, I didn't really have a lot of time to dedicate to other things. It's not fair to a student to tear their machine down just so I can make a train part or whatever, while they've got it set up to make something for themselves. So in the fall of 2021, I'd been doing some design work throughout 2021. I bought a SolidWorks license, a Fusion license, bought some 3D printers, that sort of thing. Throughout 2021 and towards the end, I had a colleague of mine in the rail preservation industry approach me about doing a fairly sizable job. I didn't know how much necessarily it was going to pay me, but I knew that if I was going to start my own business, this would be the way to do it. So I quoted the job out, and in February of 2022, I formally formed as an LLC under Huffman Machining Solutions, and that brings us to today. So my overall business is kind of broken into thirds. So a third of my business is product that I design. So I've developed and designed some products that I primarily sell for the rail preservation industry. I'll show you some of those a little bit later. A third would be job shop work specifically for the railroad industry, steam locomotives specifically. I don't really deal with passenger cars and brakes and that sort of thing, mainly for insurance purposes. But the components that I make, anybody with a lathe and a mill can manufacture. And then the other third is stuff that I do for local customers. So, people come in off the street who need a bolt made or need a part turned, stuff like that. So I'm not necessarily a job shop with a niche, but I can do just a little bit of everything. And as time goes on, I hope to expand that. So without further ado, let's take a walk around the shop and take a look at some of the machines I've got. So the first machine that I want to talk about is my WF Wells bandsaw. This is the first machine that I purchased for my shop last year in 2022. And it's kind of interesting how this saw came about. So I knew that I needed a bandsaw because every machine shop needs a bandsaw. Whether you're cutting little pieces of stock for setup or for fixtures or something, or for actual production jobs, it's always nice to have a saw around. And originally I wanted to buy just a cheapo horizontal chop saw sort of deal. But it was really hard to try to find one that was in stock. And this machine showed up about an hour away from me in a guy's weld shop, machine shop that he had. He was looking to get rid of it and downsize because he didn't quite need the power that it can put out. So I made a deal with him, purchased it, brought it in, and it was kind of a good thing that I did because one of the first jobs that I did was cutting up some steel bar. And cutting up steel bar is not the newest or the most glamorous thing in the world, but I couldn't pull the bar through my machine spindle because it was too small. And I had to hold some fairly tight tolerances on the length in order to get nice repeatable processes. The other thing too is that I had actually reached out to my material supplier who I bought the steel from, and they wanted close to $10 per cut, and I had over 500 parts that I needed to cut. So this saw essentially paid for itself with the first job, just from the fact that I wasn't paying someone else to cut up my bar. Now this saw had a couple of issues with it when I first got it. The first thing is that it wouldn't cut anything square within 1/8 of an inch. You could cut, doesn't matter if it's square bar, round bar, whatever, it was always tapering out at 1/8 of an inch. And in some cases it was really bad. And this is a place where Practical Machinist came in handy, because in all the shops that I've worked in, I've never used any sort of bandsaw like this. We always had someone dedicated to cutting stock. They would put the stock out and then we would get it and machine it. So I didn't really know what I was getting into with bandsaws, but I knew enough to try to help. But when I didn't, I turned to Practical Machinist. I wrote a post up. I think you can still see it out there. And I got a lot of good feedback. And a lot of it was really, you know, are you running the right speeds and feeds? Are you running the right blades? Are you doing all that? Well, turns out after doing some investigation, the bandsaw blades that I had bought, a very well-known name of bandsaw, might I add, they were made incorrectly. So I ended up getting some cheap blades. I put on it and it cut square ever since. So the second machine that I added to my shop, and really what started my business for me, was this Mazak Quick Turn 250 MS. So if you're not familiar with the Mazak nomenclature, the 250 is kind of the biggest spindle size that they offer on their smaller frame machines. So this machine has a 10-inch chuck. It has a 3-inch spindle bore on the main spindle. The M stands for milling, so it does have live tooling, and it has a sub spindle, which is represented by the S. These are just really good machines. A lot of people love Mazaks for different reasons. I had never touched a Mazak machine until I got this one, but I needed something that had a sub spindle. And going out and looking online in the used market, finding a machine with a sub spindle is almost impossible. It's not impossible, but if you find one, you're going to pay an absolute premium for them, because that's what everybody wants to get into these days. And I could have obviously bought just a regular 2-axis lathe and done the work that I need to do, but I wanted something that I could grow into and also be there for me in the next 3 to 5 years as I grow, and know that I have a little bit of capacity to grow into, instead of automatically saying, I need to get rid of this 2-axis lathe because I've now outgrown it. So this machine has been great to learn, but it did have a steep learning curve, and I'll talk about that in a little bit. It did have a steep learning curve, and it had quite a few mechanical problems with it that I had to address before I got it into service. The machine doesn't have a Y-axis. A lot of people these days want to go for Y-axis machines, and I kind of kick myself in the butt a little bit every time I go to set a tool up and I can't adjust it properly to where it needs to be on center line. So that would probably be the one regret that I have with this machine, is that it doesn't have a Y-axis. But for the most part, everything that I've done on it, I don't really need the Y-axis. So it's been, other than that, it's been a great machine. So it does have a Jorgensen chip conveyor. It has Mazotrol conversational programming. It has an L&S short load bar feeder, although I haven't used the bar feeder to do any production with, because typically everything that I do is large chuck work that I have to either put in the chuck with soft jaws, or I'm running bars that are less than a foot or two in length. So I can just put a spindle liner in, throw it in there, and run. This machine has a little bit of backstory. So when I was looking to buy a lathe, and I knew that I wanted a sub spindle, I was open to looking at any brand that was out there. I was not loyal to any specific brand. And I quickly found out that if you want to get a new sub spindle lathe from someone such as Mazak, you're going to spend anywhere from $180,000 to $220,000 for their entry-level machines. Obviously, the more premium machines are going to cost a lot more than that. So I obviously knew straight off the bat I couldn't go the new route. But even the used route, these things are kind of worth gold. And it really came down to two machines that I found. I found an Okuma L300MW, which is the same sort of setup as the Mazak, and the 250 MS that you see in front of you. The 250 MS kind of won out because I was able to negotiate the price a little bit lower, and it was a lot closer to me, so trucking and rigging it would be a little bit cheaper than the other one, which was in Florida. As it come to find out though, after the dealer that I bought it from had their inspection done on it, the sub spindle was actually completely shot on it. They could turn it on, they could spin it over, and it sounded like you were running rocks through a coffee maker almost. So the sub spindle in it was shot, and because I needed the sub spindle to do the work that I'm doing, it really put me in a bind. So I ended up having to tear this machine apart. Even before I even got it, I actually had to go to Georgia, where it was located previously, remove the sub spindle while it was still there, take the sub spindle off and get it rebuilt at a company here in North Carolina. Got it rebuilt, and that rebuild for the sub spindle was $15,000. So you want to talk about a learning experience? That was a major learning experience, because it was a extremely unplanned cost that I didn't intend to spend right off the bat. But looking back, if I could have changed something, I don't think I would, because after getting the sub spindle rebuilt on this machine, it has been fantastic. It will hold plus or minus 5/10 all day long once you get it warmed up. On a summer day, it'll hold a couple tenths all day long. In the winter, it's a little bit, it moves around a little bit more. And it's done everything that I need to do. I have had to adjust some sensors and things, but other than that, been a very, very good machine. My plans going forward though is that as I grow and I get more work, I would like to add a Y-axis machine so that I can do more of that complicated milling work. But as you'll see in a little bit when we talk about the next machine, it's not as important that I have a ton of milling capability in the lathe itself, because I can pull it off and put it on a milling machine if I have to. But it's just so nice to be able to do one and done type parts where you do all of your live tool milling, all of your holes, anything within the same setup, so that it's accurate, it's complete. You take it off out of the part sketcher bucket, you put it in a box, you ship it. So the most recent acquisition to my shop at the time of filming this is this Haas VF2 SS. This is a 2009 VF2 SS. It has 4th axis drive, and it has a 12K RPM spindle. No probing, no through spindle coolant. I really don't need all that fancy stuff for the type of stuff that I'm doing. But I really needed to bring milling in-house. And I don't really do anything bigger than about 12 inches long. So the VF2 being a 30x16 machine was the right choice to choose. This machine was on Facebook Marketplace of all places. A guy over in Tennessee had closed his shop down. He was selling his last few machines. I went over, took a look at it, and we made a deal. I purchased it. I got the fella that I actually purchased the bandsaw from to go move it for me. He moved it in, and we got it all hooked up with power and air a couple weeks ago at this point. And it's just a good little machine. A lot of people have their own opinions about Haas machines. I have mine, but for a 2009 machine, this machine is very, very tight. It'll hold plus minus 1 all day long, which is really what I'm shooting for. If you baby it a little bit, you could probably hit tighter tolerances. But with the 4th axis on it, it's going to open up a lot of new opportunities for me to bring in new work and revenue into the shop. But I'm still learning the machine, so there's a couple things that I need to address with it that I need to get fixed. One of them, which you can kind of see down here at the bottom of the screen here, is the enclosure around the Y-axis casting had quite a bit of eaten up and broken silicone, and I didn't notice this after I got my coolant put in it. So I was running the machine, and all of a sudden I looked down and there's just a puddle of coolant underneath the machine. I thought originally the coolant was missing the coolant tank, it was draining into the floor, but it turns out it was leaking from a seal that had rotted out. So I had to go through and address that. There's also a problem with the drawbar in the machine. So whenever you go to release a tool, it sounds like it's banging really hard into it. So I need to address that, but otherwise, as far as I can tell right now, it's a good machine. I hope it does well for me going forward, because here in the last little bit, I haven't done too many mill jobs, but I just finished up a mill job yesterday, as a matter of fact, machining just some simple little steel parts for somebody. And in the next month or two, I'll have a little bit more production work to go through it. But again, just a nice solid little machine to get started. I've got a selection of different projects and parts that I'm working on or that I have done in the past. And in the last little bit, I've really pushed myself to go after doing more complex work, because everyone can turn plastic, everyone can mill aluminum if you know what you're doing. But it takes some amount of skill to try to do something like 17-4 stainless steel, or to do it efficiently and produce good quality surfaces and components for your customers. So one of the things that I've been working on in the last little bit, these are grease fittings for steam locomotive side rods. This is an original one here, and this is my replica. I'm still working on getting this finalized. It's taken longer than it should because I'm working on this as time allows, but these grease fittings are hardened out of a 4140 or a tool steel or something. So I've made the replacement out of 4140, and it will be heat treated as well. The difference between mine and the original version is mine will have updated internals. So the updated internals will prevent it from clogging and getting jammed up whenever you try to put grease in it. These are specifically for hard grease applications. So steam locomotives specifically use a hard grease. It almost looks like a bar of clay. It has a very high lubrication content as it gets warm and melts. And these grease fittings were made for, I don't know how many years, but they were made for decades. And you can still find new old stock ones out there, but they're usually either missing the internals or the heads of them are messed up. So I hope that this is a very successful project and that it can help out many different places that have locomotives that have this style of grease fitting on them. So that's one project that I've been working on. Over the summer, I finished manufacturing these components here for a organization in Kentucky. And what these components are stay bolt caps and sleeves. So on a steam locomotive, the firebox is held together. There's two sections to it. There's an inner portion and an outer portion. And the outer portion and the inner portion are held together with something called a stay bolt. Old-timey locomotives built before 1910, 1920-ish had what were called rigid stay bolts. So rigid stay bolts were essentially a piece of all thread, if you want to put it in perspective. A little bit more complicated than a piece of all thread, but as the locomotive is fired up and it expands and contracts, it puts a lot of pressure and compression and tension on that bolt. So over time they would break. So you have to take the locomotive down, cut it out, weld up the area where the bolt was, rethread it, put a new bolt in. And on some of these larger locomotives, they might grow by a couple of inches, and you'd be breaking bolts all the time. So what they did is they developed something called a flexible system. So a flexible stay bolt is essentially a threaded bolt on one end. The other end has a ball on it. That ball interfaces with the spherical radius in the bottom of the sleeve, and as the inner firebox sheet expands, it sort of releases itself from the sleeve and allows a little bit of movement in there. So these components, whenever you go through and you rebuild a locomotive, they typically get trashed because they're corroded, pitted, and whatnot, and you end up having to replace them. These are manufactured from a really low carbon steel. It's very gummy to turn. It's very difficult to break a chip, but you can get some good surface finishes if you get your speeds and feeds dialed in. The most critical part about these components is that the threads have to be very, very well done. And the bottom of this seat down here has to be fairly accurate because there's a copper crush washer that goes in the bottom of this. It meets up with this cap whenever you thread it together. You torque these to a certain amount. That copper washer sort of presses out kind of like it would in a hydraulic application, and it seals this up. So if you do this correctly, once you install your stay bolt, pending the stay bolt never breaks, this should never come back apart. The difference with the ones that I've manufactured compared to historic ones is mine, I put a hex on so that you can put just a regular socket on top of them. Original ones have a square head, which are a little bit more difficult to work with. I think the hex head is far superior, and it's also easier to machine. You can't just make these out of any old regular steel, though. These have to be made out of a special type of steel, and that can be somewhat of a dividing cost because some people in the past in the railroad world have tried to get around that by using regular crappy grades of steel that aren't specifically made for pressure vessels, and that's a no-no. So we always use top quality steel that comes from reputable suppliers with the material certifications to back it up, so that you get good components that are to spec, that are within spec, that will pass your inspections as you go through time. The last project that I most recently did was I manufactured a set of injector nozzles for a locomotive in Maryland. And the injectors on this locomotive were functioning, but they weren't functioning where they should be. Injectors, if they're properly tuned up and set right, should be able to inject loads of water in a certain given time period, and these were not functioning correctly at all. So we went through and we manufactured brand new nozzles for them. So these components are the same. This one has the piece on top of it, but these are very fun to make. Manufactured from 17.4 stainless steel in the hardest condition that you can buy it in. Started with billet, turned the billet down. These components required some very specific things. So one, they had to be very tight tolerance. The drawing for most of the dimensions wanted plus or minus 5, but quite a few dimensions were usually plus or minus 1 or plus or minus 5/10. So this whole component, with the exception of these holes that you see here, was all made inside the Mazak turning center. I would start by roughing it. I would come in with a really nice finish insert and try to get as fine of a finish on this as I could. Then I would come through and polish it by hand just to make sure that any tool marks in this were taken out. This was a bit of a challenging component to make because of the internal tapers and how thin the wall gets here, as well as the fact that there's a groove here with a thread in it. So if I pull up the drawing here, you can see you have a lot of little intricate features, and also the whole thing is in metric. This print was last drawn in 1952. So that just gives you an idea of how old some of this technology is. But I'm glad to report, I'll pop some pictures up here on the screen of the entire injector body and the injector nozzles that I made. But I'm happy to report that the customer was very, very satisfied with the work done, and their injectors now work better than they ever have. So, of course, like I said, I've done work for other people, stuff that I can't really show or stuff that isn't as interesting, but that just gives you kind of an idea of the type of stuff that I've done here and what I'm capable of doing. So I hope you've enjoyed a shop tour of my little shop. Again, I don't have the nicest machines in the world. I don't have the prettiest machines in the world, and I don't do the most interesting work, but I have a very interesting story to tell. Maybe I'll make a video and put it up on my own YouTube channel stating some of the things that I wasn't able to say in this video. But overall, I'm very happy with the way things have been going. I'm very happy for the future. I'm very invested in the education of the future engineers and machinists in the U.S. And in North America specifically. And I want to see more manufacturing come back here. But if we do it, we've got to do it smart. We've got to do it efficiently. We've got to do it in the best way we can. For me personally, as our business owner in my shop and what I've got going on here, of course, I'd like to add more machines. I don't know if I can necessarily afford to do that right now, but as time goes on, I would like to get into, you know, a Y-axis turning center, maybe a little bit larger mill, so I can do some more involved, larger parts, that sort of thing. And as time goes on, I probably will pursue this full time. I don't know when that will happen, but I will probably always stay in education to some form or another, maybe teaching part-time again. I don't know. I just have to see where the future goes. Before I leave here, I'd like to give a big thank you and a big shout out to Practical Machinist for asking me to do this. I thought about it, like, why would anybody want to hear about what I have to do? I'm just a little dot on the map compared to some of these other guys out there. But I have an interesting story to tell, so I hope that you all found that interesting. I hope you found what I have here interesting as well. if I can start a business and can find a niche market to fit into, anybody can do anything they set their mind to. So I'm always looking for new work. So if you happen to have work that would be good for a dual spindle lathe or a 30 by 16 mill, send me an email, chris@huffmanmachining.com. You can look me up on the internet as well at www.huffmanmachining.com. You can find me on Instagram at cwhuffman01 or on Facebook. So I'm out there. I appreciate your time. Thank you very much. Have a great day.